Okay, can you see my presentation slides?
Yep, you sure can. You are actually, we have the whole PowerPoint.
Okay. Okay.
Go ahead and hit the present button.
Okay. Okay, I will begin my presentation. Yeah.
Perfect.
Hi everyone, I'm Deliang Wang from Beijing Normal University, and my presentation title is Interpreting Deep Knowledge Tracing Model on EdNet Dataset. And before my formal presentation, I want to make a brief introduction about my university and my lab. And Beijing Normal University is one of the most famous universities in China, especially in education and psychology research. And my lab belongs to the Advanced Innovation Center for Future Education. We have more than 100 full-time researchers and engineers. We publish more than 300 journal articles, 50 patents and software copyrights, and we also cooperate with researchers from other organizations such as CMU and UCL. And let's begin our formal presentation. Okay, what we do in this paper. In one word, we interpret deep knowledge tracing model with an interpreting method called LRP on a large-scale dataset, EdNet. And the preliminary experiment results show the effectiveness of the interpreting techniques, but meanwhile, more questions have to be discussed further. First, let's begin our introduction part. As we know, deep neural networks have been introduced to the training domain for better performance. So up to now, there are about over 20 deep learning-based knowledge tracing models, but they also suffer from the interpretability issue. And the interpretability issue is partially tackled in our previous work, which is published in AIEd 2020, but we are based on the ASSISTment datasets, whose size is relatively small. So we wonder whether similar interpreting performance can be achieved when we build the DLKT model on the large-scale dataset EdNet. Hence, we begin our research. And the second part is the related work part. First, let's begin our KT part related work. And as we know, KT models can be divided into DKT and DKT-like models, logistic regression, and deep learning-based KT models. And we also list some commonly used KT datasets here, but compared to EdNet, all the formal KT datasets belong to datasets of moderate size. To the best of our knowledge, EdNet is the largest dataset in education. And another part of the related work is Explainable AI. The objective is to help end users to understand deep learning model outputs and even its inner working mechanism. And it can be divided into ad hoc interpretability and post hoc interpretability. And ad hoc means training self-explainable machine learning models. The post hoc means we have to explain the model from the whole logic of or from the perspective of the contribution of inputs to the outputs. And the interpreting method we adopt here is called LRP. It belongs to the post hoc interpretability method. Its full name is layer-wise relevance propagation. It is to analyze the contribution of inputs for explaining decisions through backpropagating. And you know, the DKT model is based on the long short-term memory networks, right? So there are two kinds of neural connections in the DKT, weighted linear connection and multiplicative connections. So we have to design two LRP rules to calculate the LRP relevance. With the LRP method, we can backpropagate the relevance score of the target process from the output layer into the input layer. And then we move into our main part, interpreting DKT model using EdNet. First, we built our DKT model on the EdNet. We pre-process the 21 dataset, and we train the model with the STM network. Finally, we got 0.65 in AUC and 0.68 in accuracy. And then we interpret the model. Specifically, we design test data into sequences with a length of 15. For each sequence, we take the first 14 questions as the input and the last one to validate the model's prediction. And then we conduct 2 experiments to interpret it: consistency experiment and deletion experiment. And the first experiment is consistency experiment, which chooses the correctly predicted sequences. We want to investigate whether the size of the calculated relevance value is consistent with the correctness of learner's answers or not. If it is right, the correctly answered questions will always have a positive relevance value, and the falsely answered questions will always have a negative relevance value. When we define such questions as consistent questions, the percentage of consistent questions in each sequence is called consistent rate. And here the picture is the result. And we can see both in positive prediction group and in negative prediction group, the majority of sequences achieve 90% or higher consistent rate, which means the correctly answered questions will always have a positive will always have a positive contribution to the final prediction probability, and the falsely answered questions will always have a negative contribution to the final prediction probability. It partially validates the feasibility to use LRP method to interpret the DLKT model. But whether the findings of our consistency experiment is right or not depends on the validity of the LRP relevance. So we conduct another experiment. We want to further investigate the quantity of the LRP relevance by deleting questions according to the LRP relevance we calculate. Specifically, for positive prediction groups, we delete the questions in the decreasing order of LRP relevance. For negative prediction groups, we delete questions in the increasing order of the LRP relevance. And we can see the result. Compared to the random deletion, deleting questions according to the LRP method can significantly decrease or increase the prediction accuracy of the DLKT model, right? So it validates the LRP relevance. So through the 2 experiments, our findings are performing the LRP method on EdNet can achieve similar interpreting performance on ASSISTment dataset. It partially validates the effectiveness of the LRP method for tackling interpretability issue of the DLKT model. But the findings are just preliminary results. There are more issues to be discussed. For example, the EdNet dataset is very large. It contains a lot of long sequences, such as sequences with a length over 200. So whether the interpreting method is still effective on long sequences, it is a question to be discussed further. And the second question is, the questions in the EdNet are usually tackled with multiple scales. So how to tackle scale level interpretability issues on EdNet? It is another problem to be discussed. And the third one, how to design a more accurate and effective interpreting method by leveraging hierarchical structure information of EdNet. So this is the future research direction of our work. And that is my presentation. Thank you.
Oh, excellent. Hey, thank you very much. And by the way, when you actually say the hierarchical aspect, and by the way, as I just said this, actually, I encourage anyone else to put a question in the chat. But I'll start you up here with when you say the hierarchical nature. Oh, hi, I can see you now.
Hi.
Nice to see you. And so when you said the hierarchical nature, actually, when I sometimes hear the word hierarchical nature, I sometimes think about how knowledge components could be put in hierarchies, where maybe you need to know how to multiply before add. There's other types of hierarchies. Which type of hierarchy are you referring to?
Yeah, I mean, just as the information in the internet paper, we see some description about the hierarchical structure in the internet. So we want to use those hierarchical structure to interpret the deep knowledge tracing model.
Yeah, okay, so that's a piece of future work.
Yeah.
Excellent. By the way, thank you for joining me. And did I understand correctly that you are joining us from China right now?
Yeah, it is already close to 3 a.m. in China. Yeah.
Excellent. Well, actually, by the way, can I ask you the question that I was asking the gentleman? Well, actually, anyways, well, I was going to ask you the same question I was going to ask actually the gentleman so far. But have you had a chance to actually look at the other papers in this section? Because I guess actually I'm trying to figure out what are, there's a bunch of people that are in this room that actually aren't asking questions right now because they're probably like overwhelmed by what is this knowledge tracing stuff? What is this deep learning sort of stuff? Are there takeaways that we can actually interpret actually for other people here about this? I kind of got, yeah, well, I'm trying to imagine, suppose I'm your grandmother actually, and trying to understand what the heck actually are we doing here, and actually what is the implication? What might you tell your grandmother?
About my interpretation?
Yeah, I'm trying to rise up out of the weeds here for a second to try to actually make sure other people here might understand better. Because do you have any high level interpretation that you actually want to leave actually the audience here with?
High level interpretation, I'm not sure, but actually my paper just conveys, a main meaning, which is, the correctly answered question will always have a positive contribution to the final, prediction probability, and the falsely answered questions will always have a negative contribution to the final prediction probability. Actually, it is a very, how to say, a very you can understand, maybe you can feel how the DLKT model works. It is a general, I don't know how to describe it, but through the experimental result, you can, have a very general idea about how DLKT model works.
Yeah. Well, I think that's a good. Well, I really like what you said, which is actually like, even my actually school teacher wouldn't be able to understand what you just said about, the probability of actually getting it right is going to go up actually as you succeed actually, and vice versa. Well, anyways, I recognize that you're not going to be able to stick around for the final discussion actually, since you actually your time zone's all off, and so. But why don't we thank our speaker actually, really nice actually hearing from you. I appreciate actually you dealing with us in our